This question asks us how to predict how we might separate a mixture of enantiomers. That's traditionally very hard to do because enantiomers have identical physical properties. They would have the same melting point, the same boiling point, they would crystallize the same, everything would be the same, all the physical properties would be the same in an achiral environment. And that's the key to answering this question. So I've already got it sketched out here. If we react these two amines with a chiral carboxylic acid, we form an acid-base pair between the nitrogen and the oxygen of the carboxylic acid. This acid-base pair is now a new molecule. These two molecules then, these two acid-base pairs, are diastereomers. Some of the stereocenters are the same, some of the stereocenters are different. These two acid-base pairs being diastereomers mean that they now have different physical properties. They would have different melting points, they would have different boiling points, they would crystallize differently. We can now separate these two diastereomeric pairs based on their physical properties. Once we've separated them, we could reverse the acid-base reaction. We could do another acid-base reaction to remove the tartaric acid, getting us back to the original molecule, but now they are resolved into their individual enantiomers. So it's not really feasible to separate enantiomers in the absence of a chiral environment, but by adding a chiral environment to the mixture, we can turn the enantiomers into diastereomers, and then we can separate them based on their physical properties.